Again, my name is Mattheos Fikardos. I am a PhD student in the National Technical University of Athens, part of the Information Management Unit Lab. And today I'm going to present you Trustproofer, which is an agentic neuro-symbolic framework for operationalizing AI trustworthiness. I will try to go a bit on details, give you as much information as I can, and I will be also happy to answer any questions on that. So this presentation is divided in three main sections. The first one is the motivation that we have and a bit of the background that we saw in the field of trustworthiness. Then we have the process which we developed to operationalize trustworthiness, which is then used by the Trustproofer, which is our agentic framework that aims to assist the practitioners with enforcing the trustworthiness of their AI systems. So starting on with the obvious, in the recent years, we've seen a massive increase, a dramatic increase actually, in the adoption of AI and specifically generative AI in multiple domain sectors and so on. So this is quite obvious at this point. This also triggered two things. The first one is the incidents, the harmful incidents of AI, which have been also increased in the recent years, with a record high of 56.4 increase over the 2023 year. And also due to these developments in the field, we have a lot of governments and legislative bodies that try to regulate the whole AI field and try to give guidelines and instructions on how to use it and operate it. Furthermore, the trustworthiness has multiple requirements, as you can see on the screen, multiple dimensions that need to be taken into account. For example, we have human agency and oversight, privacy, transparency, explainability, and so on, that make this multidimensional problem that we need to consider all of these dimensions in order to effectively operationalize and apply the trustworthiness to the AI systems. As part of our work, we started by exploring the landscape of trustworthy AI and reviewed several standards, methods, tools, and so on. But as you probably know, this is rapidly evolving, and day by day, new standards and guidelines arise in trying to help with the issue of AI trustworthiness. Something that we for sure notice here is the abundance of tools, algorithms, and methods that can be employed to either monitor or enhance the trustworthiness of AI systems. For example, some tools here we have from RAND, which has more than 233 tools for trustworthy AI. From the OECD catalog, we have more than 900 tools and more than 130 technical metrics. And from the Confiance AI, the catalog has more than 50 software components and more than 130 guides and methods. So we have a lot of tools that have been developed in recent years that try to somehow help the trustworthiness of the AI systems. But this brings us to a practical challenge. I mean, we have all these regulations, the tools and guidelines that are broadcasted to the practitioners, but usually they come as a noise. They are a bit overwhelming, and it's hard for the practitioners to apply them or try to take actions in order to increase the trustworthiness of their system, despite the fact that they might want to and are really interested in doing that. So this brings us to the main motivations that we have for our work. We wanted to know how to augment the whole life cycle of the AI system, how to inject all these aspects of trustworthiness, how to follow the risk management approach, which is the go-to approach at the moment for trustworthy AI, how to utilize the existing methodologies, and how to operationalize the whole process of making AI more trustworthy. So this effort brought us to what we call the Trustworthiness Optimization Process, or TOP, which is a process we developed for operationalizing trustworthiness. First of all, we identified 5 key principles, we call them pillars, that we need to take into account in order to, let's say, connect these guidelines, legislations, and methodologies with the actual trustworthy AI. The first one is the lifecycle dimension, where the trustworthiness must be compatible with the AI system lifecycle. Then we have the assets that play an important role on trustworthiness. This could be the application domain, the various data, the AI models, artifacts, and processes that are deployed to the AI system. Then we have the AI actors that are really necessary to have a human-centered approach, where we need to include them and engage them in order to be fully aligned with their preferences and their views on trustworthy AI. Then we have the various toolkits and algorithms, as I said before, that can be employed to monitor and increase the trustworthiness practically of the AI system. And lastly, the risk management, which must be also aligned to mitigate the related risks. So having this in mind, we developed the 4-stage process, TOP, which has the stages of identify, assess, explore, and enhance. To give you a bit more details for each one, we have a problem with animations here. Sorry. So first one is the identify. Here we want to collect the socio-technical information and requirements of the AI system. Basically, we want to engage the actors and document all the related information, the technical, but also the societal aspects and the environment of the AI system. This is really important in order to set the foundation and the groundwork to probably assess and mitigate the risks of the AI system. Then we have the assess stage. Here we want to execute a quantitative and risk assessment of the AI system. First of all, through the metrics, we generate a technical view, let's say, of the performance of the AI system, not only in terms of accuracy, but also in terms of other metrics that relate to other trustworthiness characteristics, for instance, fairness, robustness, explainability, and so on. And then we execute the risk assessment to find the risks that the system might have, and have a clear view of what are the limitations in order to mitigate the risks. Then we move on to the explore stage, where we want to search for the applicable methods and optimal solutions. So first of all, we need to find which methods, tools, or algorithms can be used in the specific instance of the AI system. And then compromise a set of solutions that could have multiple set of methods, and try to evaluate how these impact the AI system, and then compare the different solutions, having also into account the preferences of the AI actors in order to find the optimal solution that can be adopted. And lastly, with the enhance stage, we want to apply the solution to the AI system and also continue monitoring its performance to see if there are any limitations or shortcomings that are still present to the AI system. Also, it's important to note that this is an iterative process, so it not just execute once. We go through the 4 stages until we see that there are no more limitations or risks that need to be taken account. And there's also a close relationship and interaction between the AI system and the AI actor that follows the process in order to enforce trustworthiness. Moreover, as I said before, we wanted to include or be aligned with the risk management approaches. So the way that the 4 stages are constructed, they also follow the 4 main stages of the risk management. So from the perspective of risk management, we have context establishment, risk assessment, risk treatment, and residual risks that coexist with the process that we proposed. So next, I would like to also mention the importance of documentation. In our approach, we incorporate the notion of documentation cards. We refer to them as trustworthy AI cards, and their purpose is to document all these case-specific, socio-technical, legal, and ethical information of the AI system. This is a well-known approach, and there are multiple references in the literature that use such cards to document the AI systems. Our contribution here is that we want to include 3 cards, which are the AI actor card, the risk card, and the method card, that are really important in order to execute the process. The AI actor card tries to encapsulate the information from the actors and includes their roles, characteristics, and preferences. Then we have the risk card that is used in order to model the AI system into the risk management framework that is used. And lastly, the method cards that incorporate the algorithms and technical information of tools that can be used to assess or enhance the trustworthiness across multiple characteristics. The last one is really important, as we will see in the next slides, to find which tools or methods can be applied to the system. So now I'm going to give you an architectural view of the process and how this is executed. Again, in the epicenter, we have the documentation, which are the cards that we use to drive the whole process. Again, the first stage is the identify. As we said before, here we want to engage with all the stakeholders and AI actors, as well as the AI system and the risk management framework, in order to collect and record all the information that is needed in the cards. As soon as this is done, then we move to the assess. Here, based on the information in the cards and the provided assets from the AI system, such as the datasets and the models, we produce the metrics, the quantitative assessment of the AI system, which is then fed into the risk assessment. Here, a risk management framework can be employed in order to generate the assessment analysis, which is basically the performance in terms of metrics, as well as the related risks that are calculated for the AI system. And this is then given to the human supervisors in order to have a concrete overview of the status of their AI system. Next, we have, sorry, a bit laggy. Okay, then we have the explore. This is the most complicated stage, so we're going to take it a bit slow. First of all, here we want to construct a knowledge graph based on the method cards. So, okay. Yeah. So this is a really simplistic example of the knowledge graph. we construct this from the cards of the AI system and also the method cards that document the tools. So in this simple example, in the right-hand side, we have the node of the AI system, which is then connected in multiple nodes that are characteristics of the AI system instance. For example, here in the red node, we have the lifecycle stage. This could be the pre-processing phase of the AI system, which is connected to this node. And then if we follow the orange path, we can see that then this can be connected to a characteristic, for example, fairness, which is then connected to a method, a tool that can be used to mitigate some trustworthiness issues. So by constructing such graphs, we can find paths from the AI system all the way to the method cards. So this creates a list of methods that can be applied and are compatible with the current AI system. So in the next, okay, I'm having a problem here. Okay. So following on the explore stage, as soon as we have the knowledge graph and we get the applicable methods here, then these methods can be applied to the AI system in a non-production environment and enter the assessment stage again. This will generate the updated assessment of the AI system in order to have a concrete view of how these methods affect the AI system. Then, based on these assessments, we can execute a multi-criteria mechanism in order to find and comment methods. As an example here, these are some generic values. We have mainly 3 tables here. So on the top, we have the preferences of the actors. In this example, we have assigned a value for each trustworthiness characteristic. This could be also further investigated to have more fine-grained criteria, such as specific metrics or other values. Then we have the assessment. This is the performance of each method across the different criteria that we have set. And then we can execute multi-criteria methodology to recommend the optimal solutions. In this instance, we have chosen the vigor method, and with the green highlights, you can see which methods are proposed each time. So based on this, at the end, we have the proposed methods, which are the recommendation that we have to the humans of what actions they can be used and applied to the system to mitigate some trustworthiness issues. So in the next stage, as soon as the human supervisor selects which solutions they want to be applied, these are then transmitted to the system and applied to the production environment. This triggers 2 workflows. The first one is to update the documentation cards. In this phase, we need to document all the changes that happened, as well as the performance, the new performance of the AI system. And then during this time, we also want to monitor the performance of the AI system to see if it performs in an acceptable manner and try to catch any deviations or any shortcomings that may come. In this case, if there are any problems, then the process will start again and go through the cycle, trying to mitigate any shortcomings. So this is pretty much about the process. And now we move on to Trustproofer, which is the agentic approach that we have. So our thoughts here was that the problem could be also part of the solution. We have seen that the life cycle is quite complicated and the information generated there is quite overwhelming. Also, trustworthiness it's not just about risks or trying to punish the AI to do the right thing. It's about making AI better and more trusted by humans. So our idea here is how can we put AI also in the loop and try to include it in the trustworthiness process rather than just enforcing it. So the main idea here is to have an AI trustworthiness assistant that follows the trustworthiness optimization process and can help the practitioners to execute it. So an overview of the Trustproofer, which is basically a card-based agentic framework for supporting trustworthy AI. First of all, it's neuro-symbolic. As we have seen, there is a knowledge graph that is constructed with all the information of the system. And then we have also the agents, the LLM, the large language model that creates the agents, that when combined, they counterbalance their limitations. From the one hand, we have the knowledge graph that has structured semantic information that need to be taken into account. And from the other hand, we have the LLMs that provide generalability and adaptability to any use case. So for the agents, we are able to prompt multiple agents to give them specific guidelines to retrieve specific information and execute tasks with high performance in order to follow the top and stick to the provided process. Then we also emphasize the generalization of the framework, because in the case of a different AI system, we can just update the cards. This will prompt the agents with the new information and make them able to execute the different tasks based on that info. And from the perspective of the tools, we have the method cards that can be extended to include new tools or even updated versions of tools that we can consider during the trustworthiness process. And finally, as I said before, this is aligned with the proposed process and follows the 4 stages that we have seen before. Now, a bit more, again, about the environment that we create. So it's a neuro-symbolic. We have on the left-hand side the cards, the documentation cards that incorporate all the socio-technical information of the system, which are then used to create the knowledge graph. This knowledge graph, as we have said before, creates paths from the system to the methods and algorithms that can be employed to assess or enhance the trustworthiness. Then in the right-hand side, we have the neural agents, LLM-based agents that can communicate with them and also make use of tools. These tools enable them to interact with the knowledge graph, retrieve information, update information, and so on, as well as with external components. This could be the AI system, the risk management framework, and so on, enable them to take actions and fulfill the, let's say, requirements of the process. In my next slide, I provide the vision that we have about Trustproofer. So again, it's the knowledge graph and the agents that create the agentic framework. And in terms of dialogue through the stages, we have this vision. So at the identify stage, the agents can be used to ask questions and converse with the user in order to fulfill the trustworthiness cards. So they can go by each field of the card and then ask question of the user in order to retrieve the information and record it. Then in the assess stage, based on a given prompt from the user, for instance, how resistant is the system to attacks, then the expert can generate the various metrics for the AI system and report back to the human on the performance of their AI system. Then in the explore stage, the user can ask how, for example, the trustworthiness of the system can be increased, and then the agents in the background go through the knowledge graph, find the applicable methods, use the different tools in order to come up with a plan and a solution that fits the user preferences and the AI system. And in the end, in the enhanced stage, the methods can be applied again, and the agents can give an overview of the performance of the AI system. So as I said, this is the vision that we have for Trustproofer. So currently we have an architecture that we implemented to start reaching this vision. So now I'm going to showcase this one. Again, this will follow the architecture that we saw before for the process, but this time we will have also the different agents that are used. Again, starting with the symbolic knowledge in the center, we have the cards and the knowledge graph that hosts all the information that is retrieved throughout the process. Starting on with the identify stage, here we have two main phases. Is the phase to ask for the card field and then to record the information. So the information collector, the agent, uses a tool to communicate with the stakeholders or the system in order to retrieve the necessary information for the cards. This information then is communicated to the card recorder that uses a different tool in order to actually record that information to the card. So this pattern of splitting, let's say, complex tasks into 2 or 3 simpler goals or tasks is something that we saw through the implementation, where it's easier for the agents to focus on a specific task and fulfill that. So if we had only one agent for the whole, let's say, stage, this created a lot of complications and misalignment with the proposed process. So this stage now, or this pattern goes iteratively until all the cards and the information is collected from the users. So having that, then we move to the assess. Here again, we split it in 2 phases. The first one is to generate a summary of the AI system. Again, this is something that we saw empirically through implementation, where in order to not overwhelm the agents with the all the information collected, we try to summarize this information into specific bullet points that are easier for them to handle the information of the system. Then we have the assessor that takes the input from the user and then uses tools to communicate with the AI system and generate the metrics for the different assets, the data sets, models, and so on. And finally, the output of the assessor is the assessment analysis, a list of the metrics as well as some explanations as a report for the assessment of the AI system. Then we have the explore. Again, this is the most complicated one. We have 3 phases here. In the first phase, we want to find the applicable methods. So the assessment analysis is passed on to the method finder, who then employs multiple knowledge experts. We call them multiple agents that communicate with through tools with the knowledge graph in order to find the paths that we described before and ultimately find the methods that are applicable to the given instance of the AI system. So then they report back to the method finder, which then generates a list of applicable methods. Then these methods move on to the phase 2. This again an intermediary step that we found useful during implementation, where we want to create a JSON-like output from the given methods in order to automatically trigger the evaluation of these methods through the AI system. So the generated JSON includes the card information of the methods that are applied to the AI system, and then go through again the assess stage to generate the updated version of the assessment. This includes the metrics, their values for each asset, as well as some explanatory information such as the definition of the metrics, the values, and so on. Then this is split into two workflows. The first one is through the metric evaluator. Here, the agent takes the raw output of the metrics and generates a metric review. It comments on the generated metrics and makes some notes about which metrics are good, which are bad, and so on. In parallel, in order to have also a concrete evaluation of the methods and the solutions, we again execute the multi-criteria mechanism in order to have a concrete recommendation about the methods. So the metric review and the recommendation from the multi-criteria mechanism are fed into the method proposer. So this is the last agent in the Explore, where it combines the information into a comprehensive, let's say, report, which incorporates the proposed solution for the human supervisor. So again, the human supervisor is responsible for selecting which method needs to be applied. That automatically then prompts the JSON generator to generate the JSON to apply actually the methods to the system, as well as the communication with the knowledge expert to update the cards in the knowledge graph. Again, here we continue to monitor the system and make any update on the cards where necessary. Now, to give you a bit more on the implementation, we try to test this in a laboratory environment, focusing only on fairness. So we created a use case, which is a bank that uses a predictive model to classify whether individuals have an annual income that exceeds 50,000. We used the adult dataset, which is a known dataset in the fairness aspect of AI trustworthiness. And we used here for the methods, multiple metrics and enhancement methods. And for the fairness, we focused more on the AIF 360 library from IBM. And finally, this is something we want to experiment with only open source models. This includes some versions from Mistral and some from Llama. So these, again, are some preliminary results that we have. It's just to give you a deeper look on how the outputs look like at the moment. So starting on with the assess for the use case summary, as you can see, this is the generated summary from the agent. So a lot of information is fed into the agent through the cards, but then creates a really concise summary with bullet points for the most important aspects that need to be considered. This helps the following agents to don't hallucinate and not to be overwhelmed with a lot of information. I'm not going to go into deep, but as you can see, it's quite acceptable and lists all the very important factors. Then we move on to the assessment. Here, again, the agent sees the metrics generated from the model and comments on this. So we have the exact values as well as some comments about which is the ideal threshold or values, and if this is in acceptable ranges, or is it something that we need to pay attention to. Also, in the end, we see that it also says that there are potential issues in terms of race bias, which is actually correct. Then for the applicable methods, here is an example from the recommended methods. So the knowledge experts went to the knowledge graph. They explored the different paths from the system to the methods, and they reported back with their findings. So here it's actually the list of the applicable methods with a short description of that method, how it can be applied and what actually emphasizes on. So next slide. So here is the metric review. This is solely the inference of the agent. So the agent gets as input the metric values and definitions of the applied methods. In this instance, the applied methods are the metafair, Gary-fair, and adversarial debiasing. So the agent comments on these methods and how their metrics have changed and if they are acceptable or not, and finally make some recommendations of which methods will be used. But in the final recommendation, we combine also the multi-criteria mechanism, that it's more concrete. It's not just the inference of the model. In this case, the proposed methods were adversarial debiasing and Gary-fair. So it recommends using both of them, and also to keep monitoring some key metrics that are really important for the trustworthiness of the AI system. Yeah, so just to conclude what we've been talking about today. So first of all, we've seen that trustworthiness is rapidly evolving, and there's a lot of noise on how to practically enforce it. I have shown you the process, the top trustworthiness optimization process, which includes the documentation cards, the risk management compatibility. It considers the preferences and conflicts of the system, and it can be expanded to include the tools and mitigation methods. And lastly, we also seen the Trustproofer, which aims to help practitioners follow the process and implement the trustworthiness. I also included a slide with 2 publications in this field if you want to have see any more details. And this is it from my side. Thank you very much for your attention. If you want to see more details, please visit our site through the QR code. And I'm really happy to answer any questions that may arise. Thank you.
Thank you very much. Thank you very much, Mattheos. Quite interesting presentation, and I see people giving compliments. We open for questions while people think about their questions. I start with one question. Where did you get all this knowledge from? You mean the knowledge for deciding which method to apply, what is their performance, etc.? Do you get it from a lot of AI literature? Are you searching the web for papers about different methods? Do you get them from the OECD catalog or from our catalog in Confiance.ai? So where do you get the knowledge from?
Yeah, I mean, this work was part of a project, Themis, which focused first of all in three characteristics, which were fairness, accuracy, and robustness. So at first we focused on this, and then we scraped basically the internet to find as much information as we could on this. So all the catalogs, all the methodologies, and so on, and try to document them all into the cards that are then used to create the knowledge graph and figure out which are applicable. And
so the cards were created by people, not automatically by the language model, huh?
Yeah, at this stage, yes, but we foresee that this could be also automated through the agents. But it needs a lot of attention in order to give them access to all these catalogs and be sure that they can work and document it correctly. But yeah, it could be done, I think.
It reminds me of something that we tried to do in the Confiance.ai program, but was never really achieved. We had the idea, you know, in Confiance. Okay, there is already one question coming, but I'm finishing what I'm saying, and then we open more questions. We open from this question. We said we developed a lot. We tried a lot of methods on many use cases, on many trustworthiness attributes, and we said, okay, now who is going to decide what to use when? So that's what you do with your system. Huh? And we said, let's build a companion. A companion would be on top of the environment for trustworthy AI development, where you have some kind of external software looking at what you are doing and telling, yeah, you should apply this and that method. But at that time, when we were doing that, LLMs were not that popular. So we said we develop that in other ways. And in fact, the project was never achieved. So we are without. And well, I see that you have the missing link for the work. So it's very, very interesting, and congratulations for having done that. I hope that when you go to when you scale it to the full dimension, it will still be interesting and feasible, because there's a lot to be done. Huh?
Yeah. Thank you very much. Yeah, I know there are a lot of issues that we have not seen yet, and I'm quite positive that we'll be able to resolve them. But yeah, thank you.
But generally speaking, I think it's a good idea to use an LLM or many LLMs for helping people develop these complex applications. I think it's a kind of self. How is it called? Like, you know, the self-explaining sentence, or something like that. You apply a system to itself. Huh? I wanted also to ask you how you check the trustworthiness of the LLM, but I will do that after. I think that Daryl Hond is going to ask a question first. Please.
Yeah, thanks very much for the talk. That was going to be one of my questions. Got a few questions. How do you establish the trustworthiness of Trustproofer itself? But another question, or I should make an observation as well, in that I think that, you know, this could also apply to systems which don't necessarily have AI. So the whole scheme could be applied to a different kind of system, because it's a general scheme for assessing trustworthiness. But I was going to ask, do you fine tune your LLMs to work with the knowledge graph for this particular application?
No, we do not fine tune. I mean, I think we're just fortunate enough that the LLMs progressed enough or reached a state that they can handle some basic tasks. So using tools or just processing and not so much information, or give them really strict instructions on what to do. They're good on that. So we didn't have to fine tune the model. And for the question that you both have, we don't guarantee, let's say, the trustworthiness of the LLMs. It's just experiments at this point. This is a really good question on what we should consider in the future. But at this point, through our experiments, so narrowing down their capabilities and their tasks, we see that at least for now, they don't have any significant shortcomings in this respect. So we try to constrain them as much as possible to follow the process.
Yeah, thank you.
I think you said you had many questions. Okay, there was just one. Let me just follow with the question that we both had. How do you ensure the trustworthiness of your trustworthiness agent?
Yeah. So to be honest, I don't have an answer to that. We haven't focused on that, and the reason is that from our experience so far, we see that because we limit their capabilities, and they are good enough to follow the specific instructions of the process, they don't seem to have any major shortcomings in that aspect. But for sure, it's something that we will need to keep a closer look as we move on and scale up the approach.
Okay, so there's a question by Suyan Ganamani. Sorry about that. And then we have a question. Then we have a question on the chat that I will have to say the question because the person maybe doesn't want to speak. I don't know. So Suyan.
Yeah, thank you for the very interesting talk. I have two related questions. First one, the methods that you, so you also answered this earlier, you chose from, so the methods are prepared as cards by humans. Do you have any experience with more complex methods? So some of the fairness metrics are basic in the sense that they have a clear boundary on when there is fairness and when there is not fairness. If you go into a more complex metric like, I don't know, adversarial robustness, maybe the boundaries are not so clear. Do you have experience on how the system works in such situations? And then a related question is, we have this issue of trade-off, right? When you optimize for fairness, maybe you are losing accuracy. In the final step, how does the system respond to that or react when you have these trade-off like situations?
Yeah, thank you for the questions. Indeed, this is also the reason that we choose fairness for the moment, which is quite simple compared to the other characteristics. The way that we approach at least the method cards, we try to document a lot of information. So the related metrics, when it can be applied, what metrics is impactful on what assets it needs to have. For example, does it need the data, does it need the models, and so on. So we try to capture a lot of information there. We just started experimenting with robustness, actually, as you mentioned, which is a bit more complex. From what we have seen so far, these will not create any significant issues or deviations on how we use this. So the knowledge graph, at least, we constructed in a very similar manner. So we will be able to find the applicable methods. Now, for the assessment and how we handle their end results, let's say, I go back to this one. I think this will help. Again, as you said, it's not that easy to monitor or evaluate, for example, robustness. It's not a binary value, true or false. There you have like some how can I say it? Some confidence levels, let's say, and these I think will be also can be reflected in the risk management. So you have like a probability of not being robust, let's say, based on these metrics. So I think that's where it's mostly handled. Now for the conflicts, so we have not found a concrete, let's say, approach in the literature yet. The state of the art, or the most common that we found, is with the multi-criteria, where you might have some requirements at first. For example, you need a minimum accuracy of, I don't know, 80. So in this instance, you can just exclude method 4 by the beginning. So you don't even consider that. And then for the conflicts, that's the methodology with the multi-criteria. You have to balance between the different criteria. So that's why you have also the preferences. So if there is a strong preference in fairness, for example, the method that has the highest fairness outcome will be prioritized over the others. So this is pretty much how we approach this. I don't know if this answers your question.
Yeah, thank you. That answers it. Thank you.
Okay, there's 2 questions by Nina Smirnova. Nina, do you want to speak, or I can read the questions if you don't want to speak?
It's okay. It's just a little bit noisy around me, so I
there you go.
Next. Yeah. So partly you already answered my questions, but the first one you didn't answer yet, so I will ask it. So which prompt or tools you use in a way to generate final method JSON for in your agent?
Yeah, in general, we've used the Crew AI library in Python for the agents. We used some LangChain for the tools and monitoring. And for the inference, we used the Olama, which serves open source quantized models. I don't know, does this answer your question?
No, it's how you construct the agent, but I am more interested which exact prompt you use, and which tools you give access to the agent in a way to get the final JSON method.
Yeah, so yeah, for our experiments, we constructed a virtual environment of the AI system and exposed some functions that the agents see as tools, for example, to test a method or to assess on a specific metric. But they use that tool to call the environment and get back the answer. So there is the model in the environment. You call the metric, then code runs in the environment, generates the metric, and so on.
So it's custom tools you develop for this agent, right?
Excuse me, I didn't hear that.
It's custom tools that you develop specifically for your agent, right?
Yes. Okay. Yes. Yeah.
So I don't see another hand raised, I think. So yeah, please go on.
Yes, hello, can you hear me?
Yes.
Okay, because she asked for the tools, and if you want to create on-premise agents, there's a tool from Germany, it's called N8N. Maybe if you are searching for something like this, I'm working with it in Germany, and we are introducing it to make our work easier, and we are creating design descriptions with it. So if you're searching for something,
put the link in the chat. Okay.
Yeah, please.
Yes, I will send it. Otherwise, you can come to me and ask me, because in Germany we are trying to introduce it very soon. We have some technical issues with hardware and DITSing, but that's just some driver problems. I already did it on a workstation, and I know it's working. So I will send you the link to the software, and if you have any questions, you are free to ask me.
Yeah. The link has been put on the chat. And okay, thank you.
Just to ask, is this an open source?
Yes, open source. It's open source.
Okay, perfect.
Yep. So just to finish, because we will move to the next speaker very soon, I have a non-technical question. I understand that this is your PhD work.
Yep.
And so how far are you from finishing this PhD? Do you still have a lot of work to do on the tool, on the method, etc., to finish? And what will happen after you submit your PhD? Will it be maintained and kept, etc., developed by the university? What will happen?
Yeah, actually, I'm quite close on finishing. My goal is to finish this October, actually. And this work is part of my PhD, not the whole research that I'm doing. So yeah,
well, it could be enough for a PhD. At least here. I don't know in Greece, but
yeah,
it could be enough for a PhD. But anyway, please go on.
Yeah. So yes, I mean, I'm close. I think it's going really well. And for the future, I'm not really sure yet what I will do, but I will keep you updated on the outcome of this.
Okay. Since I think you are or going to be a member of the European Trustworthy AI Foundation, maybe there's an opportunity for the foundation to be involved in that. We'll see. Okay, so thank you very much, Mattheos. I think people appreciated your presentation. Nice and well organized, and many interesting questions.